these first three examples may be a review for you. In fact, we did a video and a lesson on this much earlier in the school year. So you may want to jump ahead to the second example we'll take a look at after this slide. But if you need a refresher on this, it turns out that you can't just have any three sides you want to be able to make a triangle. Something has to be true about them, and specifically, the two shortest sides in any triangle always have to add up to something bigger than the biggest side. So as simple tasks, we'll take our two shortest sides, 4 and 6. I want to add those together and see if they are bigger than the biggest side listed. And just make sure your numbers are listed in order, because they're not always, and so don't want to make a mistake because of that. So I get this statement, 10 is greater than 9, and yeah, that's true. So yes, those three segments could be used to make a triangle. When it says to explain, my explanation is just going to be my work right there. Okay, so that's all we're doing. Let's try a couple more, then we'll look at the other example like I said on the next screen. So take your two shortest sides, this time they're not in order, so just be careful of that. The two shortest sides have to add up to something bigger than the biggest side. So I add that up, and of course 20 is greater than 15. So yes, those could make a triangle as well. In fact, I know they'll make an isosceles triangle because I have two sides that are the same length. My last example, the two shortest sides are 3 and 3 and 4. So I want to know, do 3 and 4 add up to something bigger than 7? Well, be careful on this one. I get the statement, 7 is greater than 7. And you may be tempted to say yes, but no. 7's not greater than 7. 7's equal to 7. So no, those will not make a triangle. You can't use segments that are 3, 4, and 7 to make a triangle. Let's go ahead and take a look at one of these examples. This is maybe why you're watching this video. In this case, we're given two side lengths of a triangle. One side's 12 and one side's 8. And I want to know what the possibilities are for the side lengths of the third side. Well, it can't just be anything we want it to be. In fact, it turns out there's a shortest, a smallest value, and there's a largest value. So there's a range we want to find. So I'm going to show you the official mathematical way to do it, and then we'll see if we can see a shortcut. So here's what I want to do. I want to take two scenarios. Maybe our x, our missing side, maybe that's the shortest side. And so in that case, I'm going to take my two shortest sides, which are x, and then 8, the one they gave to me, and that's got to add up to something bigger than the biggest side. Remember, I'm going to assume x is the shortest side in this case. So solving that inequality gets me this statement, x has to be greater than 4. So the missing side could not be 4. Like we already said, 4 is not greater than 4, but it could be something like 4.1, that would work. Or 5 would work, or maybe 10 would work, something bigger than 4. But it can't just be as big as we want it to be, because there's a maximum value for this as well. Let's suppose, on the other end of the spectrum, let's suppose the missing side is the longest side. Well, in that case, 8 and 12 are the two short sides, and those need to add up to be something bigger than the biggest side, which is in this case x. So solving that inequality, all I do is add 8 and 12 together. And let me go ahead and flip the order of that, and be careful that the inequality symbol flips as well, just so it's more used to what we're seeing. So, what we're used to seeing. So x has to be less than 20. So in other words, I found a range of values. That missing side must be something between 4 and 20. And you may want to put a little note about it can't be 4 or 20. It has to be something bigger than 4 or less than 20. So like 16 or 15, 20 wouldn't work, 21 wouldn't work. So somewhere between those is my range of values. Now, a shortcut people found with this is, well, the numbers we were dealing with were 8 and 12, and so some people realized, well, if I do 12 plus 8, that gets me 20, the biggest it can be. And if I subtract the two sides, 12 minus 8, that gives me 4, the smallest it can be. So yeah, if you want to take that shortcut, that's fine. Just make sure you go back and word your answer something like this. We want to come up with a range of values. The missing side in this case must be between 4 and 20 units, and it can't be equal to 4 or 20.